In this video, we are going to do these three questions from the chapter Application of Derivative, and they are from the topic that is maxima minima. As you can see, we have to find greatest rectangle, minimize the length, and the nearest point to him, right? These are the terms used to figure out that they are questions of maxima and minima. So let's begin with the first question. In this question from the chapter Application of Derivative, it says find the area of the greatest rectangle that can be inscribed in an ellipse, and this is the equation of the ellipse given over here. So first thing which we will do is to make a Cartesian plane, and I'm going to make one ellipse over here. So this is the ellipse. Now we have to make a rectangle, right, which is occupying the maximum area, right? From this, whatever the rectangle that we can make, this can be several rectangles, infinite, in fact, rectangles can be made, but then we have to look for the one which has the greatest area. So we have to maximize the area over here. Now, what you need to know that any point on the ellipse, that means I'm talking about this green bottom line. So any point on the ellipse is in the form of, it is in the form of a cos theta, well, it's x coordinate, and b sine theta, it's y coordinate, right? So if I name this rectangle as say ABCD, the longer one is ABCD. So from here, what you can conclude that this length is going to be a cos theta, and so is, well, the coordinate may be minus a cos theta, but we are talking about just the length. So it's going to be a cos theta plus a cos theta, that is 2 times a cos theta. So I'll say that the length over here is 2a cos theta, and the width or the breadth is going to be b sine theta plus b sine theta, that is the breadth will be 2b sine theta. Now we have to find the area, and area of a rectangle is what? Length into breadth, right? So let's say if I find the area of this rectangle. So area of rectangle is length multiplied by breadth. L into B. So replacing L with what? Multiplying these two, right? So I can see that it is 2a into 2a. That should be 4ab sine theta dot cos theta. So we can minimize it. I can write this as, let's say, if I keep 1, 2 over here instead of this 4, this is because we know that 2 sine theta dot cos theta is sine 2 theta. So I can write this as 2ab sine 2 theta. Next is to find its derivative, right? Because we have to, in case of minimizing or maximizing, we have to find its derivative. So let's say this is dA by d theta, right? With respect to theta, dA over d theta, 2ab will be there, and sine theta derivative is what? Positive cos theta. So it's going to be cos 2 theta, and for 2 theta we'll have 1, 2 over here. Let's accommodate over here only. Right. This way we get its first order derivative. Now I'll also find its second order derivative. This was, now this is d square a by d theta square. D square a by d theta square is going to be, the derivative of this is how much? This 4ab will be there, and cos 2 theta derivative is what? Minus sine 2 theta. So minus sine 2 theta, and we have a 2 also for the chain rule of derivative of 2 theta. Now clearly this is coming as what? Negative, right? This is less than 0. This is coming as less than 0. So therefore, we'll say it's a minima. But then we have to find the length and the breadth. For that, we need theta over here. So I'm going to equate this with theta. That is this thing which is 4ab cos 2 theta equals 0. This implies what? Cos 2 theta is 0. So cos theta is 0 when theta is how much? 90 degrees. So I can say 2 theta is actually pi by 2. So theta should be pi by 4. Right. This is cos 2 theta, and we know that this angle should be pi by 2 as cos 90 is 0. So if 2 theta is pi by 2, theta is pi by 4. Now we have to get the area. We can plug in the value of theta over here, right? So that's what we are going to do. So this is area is equal to 2ab sine 2 theta. That means sine 2 theta is pi by 4. That is sine, not pi by 4, pi by 2, sine pi by 2. And sine pi by 2 is what? Sine 91. So we'll say that 2ab into 1. So therefore, this is the maximum area or the greatest area. In the next question, it says an Apache helicopter is Apache. Yeah. Helicopter of enemy is flying along the curve, and the curve equation is given as y is equal to x square plus 7. A soldier placed at a point that is 3, 7 wants to shoot down the helicopter when it is nearest to him. So we have to find the nearest distance. So let's say this be any curve, and the equation I take this as given, which is x square plus 7. And say this is flying along this path. This is the path along which it is flying, and there is a soldier somewhere. Say I take this point as S, and the coordinate of this is 3, 7. So you want to shoot when it is nearest. I mean, this helicopter when is moving along this path and want to shoot when it is nearest to him. So let's say this be the nearest distance. If I draw the nearest distance, we have to minimize this distance, right? So let's say if I take distance as d, and let's say this is point P, and the coordinate of this P, say x, y. So what we know that if I take the x coordinate of P as x, right, its y coordinate is what? Y coordinate is x squared plus 7. Right, one more time. If I take x coordinate as x, then y is what? The y coordinate of this point is x squared plus 7. And we know the point S over here, which is 3, 7. And we have to find the distance. So if I say distance, it's going to be what? This, I'll find the square of the distance, which is x2 minus x1 whole square. That is x minus 3 whole square plus y2 minus y1. This is, say, y2 minus y1 whole square. So d square comes out. So now we'll do expansion over here. That is d square comes out to be, this is x square minus 2ab plus b square is what? 9. Here this get cancelled. So we have x square whole square. That is x raised to the power 4, right? Yeah, that should be x raised to the power 4. Now simplifying it, this is x raised to the power 4 plus x square minus 6x plus 9. So I'm taking d square as z minimizes, d square also minimizes. So z is equal to x raised to the power 4 plus x square minus 6x plus 9. So if I differentiate this with respect to x, this is going to be what? 3x, 4x. This would be 4x raised to the power 3 plus 2x minus 3. Right, and then if I find its double derivative, this is d square z by dx square is going to be what? This is 12x square plus 2, right? It should be 12x square plus 2. That should be 2. Okay, I did a mistake. This is 6. Right. Okay, so now its double derivative is unaffected. So this is 12x square plus 2. As you know, square of a number is always positive. That multiplied by positive 12 with added 12 will be greater than 0. So therefore, we say that hence it is minima. Now we need to find. So next to equate this with 0. So we know that it's necessary to first of all write down that for maxima or minima, dz over dx has to be equal to 0. So that means this is equal to 0. So let's see if I do it over here. This is 4x cube 4x cube plus 2x minus 6 equals 0. So I can take 2 common. So that way it will give you 2x square plus x minus 3 equals 0. The next thing is to factorize. Well, I'll use hit and trial method depending upon how you have done in lower classes. Maybe the long division also you can apply. And this is cube, not square. Now check here. I can see that 1 is the 0 of this polynomial. That means x minus 1 is a factor. So that's why I'm writing this as 2x cube minus 2x square and then plus 2x square. We need minus, so minus 2x, it was x, so to restore I'll add 3x minus 3. Well, you can apply any method you have learned for factorizing a cubic polynomial. So from these two I can take 2x square common, so we get x minus 1. This if I take 2x as common, this is x minus 1 again. If I take 3 common from here, this is x minus 1 again. So we can see that x minus 1 is common throughout, and therefore this is 2x square plus 2x plus 3 equals 0. Now this cannot be 0, right, as they are having positive values, or even the discriminant for this part, right? What I mean to say that the discriminant of this part is less than 0. So is a no real root for this part. D is less than 0. Therefore, we'll be equating x minus 1 with 0. So equating x minus 1 with 0, we got x as 1 over here. Right, we got x1. Now we have to find the distance. And for distance, you can replace the value of x in this. This one is the shortest. You can place anywhere. I find this is the shortest one. So to find the distance over here, you are simply going to place the value of x. What is x here? X is 1, right? So 1 minus 3 is minus 2 whole square is 4. And this is x square, that is 1 square is 1, whole square is 1. So that means distance comes out to be under root 5. Yes, we'll say that this is the nearest distance. That is under root 5. In this question, it says a point on the hypotenuse of a triangle has to be a right angle triangle are at a distance of a and b from the sides of the triangle. So what we are going to do is to first to make a right angle triangle. Let's say I made this right angle triangle and say I name this as ABC. And they're saying there is a point on the hypotenuse anywhere. Let's say I took this point as P over here, and its distance from the distance has to be perpendicular distance are A and B. So this is say B. Now what we know that these lines are parallel. So this angle, if I take theta, so this will also be theta. Now we have to get AP plus PC. So what is AP? So as of now, I'm taking this as X and Y. So we need a relation between A and X. So this is base and hypotenuse. So I'm going to take sec theta. Well, I need to mention the triangle. Here I'm talking about this triangle. So in this triangle, sec theta is what? Sec is hypotenuse over base. So this implies X comes out to be A sec theta. Similarly, for the other triangle, this time I'm taking this triangle. So in this triangle, I'm taking cosecant. Cosec theta is what? This time it will give you y over b. And from here we can say y is equal to b cosec theta. Now we have to get the hypotenuse, and hypotenuse is what? X plus y, right? So we can say that AC is how much? A sec theta plus b cosec theta. Now next is to find its differentiation. So differentiating this with respect to theta. So sec theta is what? Sec theta tan theta and b as it is. And for cosec it is minus. So I'll place minus before it. So this is minus cosec theta dot cot theta. Next, we are going to equate this with 0. We'll find its double derivative later. First, let me equate this with 0. On equating this with 0, what we get? We get a, I need to show that for maxima or minima, dA by d theta has to be 0. This implies that on equating this with 0, what we are getting? We are getting a secant theta tan theta is equal to b cosec theta dot cot theta. So let's convert them into sine cos. So this is a, and this is what? 1 over sine, right? So this is cosec, sec is 1 over cos, and this is sine theta over cos theta. B cosec is 1 by sine, and this is cos by sine, cos theta by sine theta. So on cross multiplication, we are getting what? Sine cube theta on the left hand side. This is sine cube theta, and bringing cos to the left, this is cos cube theta is equal to what? B by A. This implies that tan cube theta is B by A, and we can say therefore tan theta is equal to B by A raised to the power 1 by 3. We got this tan now. But then we also need to show that its double derivative is positive, right? Because this is because we have to minimize. So if I find its double derivative, this is d square A by d theta square. So we are going to use product rule over here. A as it is, secant square theta is secant theta dot tan theta, right? Secant theta dot tan theta. We have already at theta, so that's why tan square theta. Plus, this is going to be secant theta as it is. And then tan square theta is what? Secant square theta. So I can write secant cube theta. We have minus outside, B, and then cosecant theta is minus cosec cot. So minus cosec theta dot cot theta. And ordinarily we place a plus, but cot derivative is what? Minus cosec. So I'll write minus cosec theta, cosec square theta, but then we have another cosec. So that's why cosec cube. Now, if I take minus common from here, if I take minus common from this will be positive and this will be positive. Now, what you need to see in the diagram that we have this angle as what? Acute angle, right? It's very clear. In a right angle triangle, if one angle is 90, the other two has to be acute. So if this is acute, so you may need to write down theta being here, what is less than, or maybe first quadrant you can write. Therefore, this is going to be positive. That is d square A C over d theta square is positive. Hence, minima. Now what we had to find out, we got tan theta, right? But then if you look into the question, we have to minimize the side, and the side was not this. The side was, yeah, this was outside. Where is that gone? That's AC. Okay. This is what we have to minimize. I can copy it from here. This is what we have to minimize. So I should write it below so it's clear to you. So for that, we need secant and cosecant theta, and we got tan over here. So we are going to once again use this triangle property. So if I take this as theta, we have tan, and tan is what? Perpendicular from here, right? Perpendicular over base, and base is this. So I can use the Pythagoras relation and say that this is 2 by 3, like square of this plus the square of the other side, whole under root. So from here we can get AC. AC is what? Secant theta. Secant is hypotenuse over base. So hypotenuse is A raised to the power 2 by 3 plus B raised to the power 2 by 3 whole under root. And base is A raised to the power 1 by 3. This is B. Cosec is hypotenuse over perpendicular. So this is A raised to the power 2 by 3 plus B raised to the power 2 by 3 whole raised to the power B raised to the power 1 by 3. Now from here, I can see that I can take this as common, that is whole under root a raised to the power 2 by 3 plus b raised to the power 2 by 3. So it result to give you what? We are left with a over a raised to the power 1 by 3 plus b over b raised to the power 1 by 3. Next, continuing with this, we have AC now as under root a raised to the power 2 by 3 plus b raised to the power 2 by 3. This one simplifying, same basis, divided, power subtracted. So 1 minus 1 by 3 is 2 by 3, and same over here. This is what? This is actually a half power, right? This is a half power, and this is 1. Again, applying the laws of exponent, what you can see from here that AC comes out to be a raised to the power 2 by 3 plus b raised to the power 2 by 3. 1 plus half is 3 by 2. So this is what we got. And if I type the question, what was the question over here? Not this one. The question was, what I have to verify over here. Let me see over here. Yeah, this is what the question was, to minimize, right? And we got this as, it has to be a raised to the power 2 by 3 plus b raised to the power 2 by 3 whole raised to the power 3 by 2. That's what we got. A raised to the power 2 by 3, b raised to the power 2 by 3 whole raised to the power 3 by 2.